I'm Jim McLaughlin, and this is the second anthropometry lecture. And I want to cover a few things that were not covered in the first lecture on anthropometry. First, it's important to understand that it's just not a length and width. There are several ways in which the body can be measured. Length, it's obviously used to name a distance between two landmarks. So we're not just talking about overall stature. When we measure somebody, we can measure their length, for example, from the bottom of their foot to their knee, from the knee to the hip, and so on. The depth, this is the distance between two landmarks found in the anterior and posterior surface of the body along the x-axis. So this would be, for example, from the stomach to the back. The breadth, this is the distance between 2 points found on the left and right sides of the body, so this would be across the body from side to side, let's say from hip to hip, shoulder to shoulder. The arc is a curvilinear or surface contour distance between 2 points on the body, often on the head or face, so this would be a measure around a certain area, for example, that you would be doing a fitting. In this case here, such interest would be for fitting people with respirators and so on, so design of respirators so that it fits the majority of faces, and measurement of arc is important toward that end. Circumference, this is the curvilinear contour that provides a distance completely around the body part. In most instances, circumference is located perpendicular to the longitudinal axis of the body. In this case would be, let's say, measurement of the circumference of the head. Hat sizes, for example, would go into place. So in the case of occupational ergonomics would be safety helmets and circumference around the neck size, make sure that there's good fit with the neck and around the belt and so on. Then there's reach. This is the arm distance in a perpendicular posture or condition, and there are various kinds of reaches. There are what's called just normal reach, then there are functional reaches, and so on. So it's important to recognize that in anthropometry we're looking at a number of dimensions: length, depth, breadth, arc, circumference, and reach. Ways of measuring these various anthropometric distances can be done with an anthropometer, as you can see on the left side of the screen, and with calipers, spreading calipers, large and small. And the nice thing about the calipers is that it gives you a much more accurate measurement of distance, especially if you're looking at width and depth, let's say going from hip to hip or shoulder to shoulder, rather than using a tape measure. There are some measurement errors associated with tape measures, and the calipers tend to help bring the error down quite a bit, and reducing measurements between one individual and another. Calipers can also be used for different parts of the body. For example, looking at the distance between the eyes, the width of the nose, nose bridge, and so on. The normal distribution curve and relative proportions of the population are represented by standard deviations, as you can see here, with the mean in the center. Then we have our one standard deviation going at 34% of the population on each end, minus and plus. So this would represent, let's say, something larger than the mean, heading to the right of the screen, and to the left of the screen something smaller than the mean. And you can see that we get into 1, 2, 3 standard deviations out, where we look at the different percentages of the population. So for one standard deviation, it's 34% of the population on either side of the curve. For 2 standard deviations, 47.5%, and then for 3 standard deviations, 49.9% of the population on each side of this curve. How this comes into play is that when we look at information from measurements of the 5th percentile of male and female, the 95th percentile male and female, and we look at the different segments, the floor to lateral malleus or the lateral malleus to lateral femoral epicondyle, you can see that these are the measurements that are gathered from the data. These are the measurement points down here that relate to that. ANSUR, it deals with the stature, deals with an Army survey that had been done for anthropometry. So the Anthropometry survey is what that stands for. And the thing to point out is that when you look at these measurements between these segments that are lined up here, and you start adding them up, is that what happens is that you'll see the sum of the segments, and then you'll see the answer stature right here. And notice the difference between the segments and the stature. And this is not a measurement error. What it measures is that there are differences in lengths with individuals in measuring these. And because of the differences in those lengths, you have this difference between the segments and the stature overall. So, for example, what it's saying is that some people have longer legs, upper to lower legs, longer arms, upper to lower, a longer or shorter torso, and so on, relative to their overall stature. So that brings home the point when I talk about no one really being average. So even if you were of average stature, there may be differences in your body lengths or proportions that would account for these differences here. The same thing for females, of course, as well as in the 95th percentile in lengths for the male and the female for as much as 9.93 in terms of the differences that we're measuring for this particular data. And there's a reference if you want to see more information. A fairly large sample size for females, over 2,200, and for males 1,774. So anthropometric measurements, as I've mentioned before, can occur in a number of different ways. The standing height, for example, here, notice that these are measured at landmarks. It's the ankle, the inseam, looking at the crease in the elbow, the eye height and overall stature, sitting distances. The ones that I've emphasized in class with measurements are the popliteal to buttock distance here, the B9. And the reason for that is that we're looking at the seat pan depth, how much seat pan that we need. And if we take it from another measurement, the B8, some students make this mistake in terms of seat pan depth. This has no real relevance to seat pan depth. This is much more for something that would be looking at knee clearance. So if you were to put a desk here, for example, you would be looking at where is that clearance needed in order for someone to be able to fit a chair comfortably under a desk and be able to work from that surface. So that's where B8 would come into play. Of course, you have to also consider that you have to have a little bit of foot clearance, but a lot of times what happens is that people can move their feet back, but you still need this. You can't do anything with the knee to buttock length right there. So that's really the critical distance. For seat pan depth, B9 is, and then the other distance is B7. This would be the height of a seat right here. The height of B6, again, this would be more of value with getting your thighs underneath the desk, having clearance for that end. And then for the B7 would be the height of that chair, so an individual could sit on it comfortably with regard to their height. Also, one of the take-home points that's very important here tends to be a test question, and that is that the critical distances here, especially with the popliteal and the height right here of a chair, tend to be organized around a smaller individual, and the reason is a larger individual can sit in a smaller chair, but a smaller individual trying to sit in a larger chair is much more uncomfortable. And so when you do these calculations, realize that the outcomes are much more sensitive toward those in the smaller population sizes, especially with regard to seated workstations. If we follow this down a little bit further, we see that width issues are important, especially shoulder and at the buttock, looking at the width here from side to side. This becomes important in terms of being able to position people into spaces. One of the things, of course, that I'm well aware of is being inside airplanes and the passenger seat room that you're given. Someone my size tends to go way over this limit right here. That's one of the reasons why being in a center seat is just, I'm miserable in a center seat. I'm actually miserable in all the seats because my shoulders stick out in the aisle. The flight attendants tend to whack it when they run up and down with their carts. When I'm in a window seat, if I'm not in a place where the window is right there, then I'm pushed out, and then what happens is I move over into the middle seat area, which makes the person flying next to me uncomfortable. So I tend up being twisted in that seat. From here to here, in terms of fitting in the seat, most people fit in, it's not comfortably. I fit in the seat fine, but it's not exactly a lot of wiggle room when you're sitting in these seats. So this becomes really important in terms of width. Hands are important, obviously, in terms of being able to activate buttons. One of the interesting things about the hand that some of you may have experienced is the iPhone, the design of the iPhone 4 versus the iPhone 5. It's said that Stephen Jobs, due to his illness, didn't have a whole lot to input and override with the iPhone 5 design versus the iPhone 4. And as you know, he was a big stickler for functionality, form and function. And the problem with the iPhone 5 is because of its length to width ratio, that it makes it much more difficult in terms of the functionality to activate many of the buttons on the iPhone 5 because the thumb doesn't have the reach capabilities of moving to those buttons as easily as you would see on the version 4. So this is something that comes into play, but also safety issues and so on when dealing with the occupational environment. And foot size is also important, not only in terms of length, but in terms of width. This becomes very important in terms of functionality of operating foot presses and so on, clearances and related matters. These are the different reaches I talked about. This is the outstretched fingers. Most instances, we're really looking at this kind of reach right here where you're not twisting and reaching out. It's called this F2 is called a functional reach. It's important that you remember that because these are most of the measurements that are taken in the class and where people are able to perform a function by being able to close the index finger and thumb together to perform a simple function on a reach like this. This is an extended reach on F3 where you notice that the shoulders have rotated. It gives you more distance right here on a functional reach. And the upside is that you do get further reach, but it also assumes that you have accommodations where you can actually twist and lean forward. Think about something like this when you might be in a car with a seat belt. The seat belts hold you in place, and there's some slack in the seat belt to allow you to move around a little bit. But if you had in a situation where an emergency came up and you had to reach forward for something, and the car, for example, hits something, or you suddenly reach for it, that seat belt holds you in a place and it doesn't allow you to get into this position to reach for something that might be very, very important. Let's say a mother with a child next to her can't reach over into the passenger seat, with this kind of setup because of the lockdown of the seat belt. Overhead reaches are important. I've seen a lot of people frustrated with this, with for example, activating the lights or the call buttons on airlines, and also just being able to reach in the overhead compartments. There's obviously the sitting moment, which you really can't do very easily, but the overhead in this fashion right here for the shorter females in particular, which don't have the shoulder strength or the reach capabilities to easily get in and out of those overhead compartments. The newer model airplanes are getting a little better about that, but it's still a problem. And then the issue is that when they bring these down, to accommodate the smaller individuals. Now you've got the taller individuals running into these as they go up and down the aisle. So it's no real easy fix. These are contours showing range of motion. So this would be moving your right arm from left to right. So you can see the smaller contours here. This is the range between the small and the tall individuals. So this would be rotating your arm around, showing you a circumference, if you will, of movement, the space in which you could actively engage in controls or reach for something in this contour. This is the front contour, reaching in front. The XZ coordinates, the first one were the YZ coordinates, and these are different views that you can see in terms of reach parameters. Right here with the YZ in front of the person. This is a overhead view that you see of the reach around, and then the same thing here with the YZ vertical contours in terms of those reach envelopes that you can do with your hand and be able to activate things. So it makes sense that the arm can go around here, but reaching around to the other side, obviously it's very limited because of your body is in the way here, and that's one of the reasons why this becomes like it is. And then but you can reach around and come around the other way and touch. These are the mid-sagittal planes, by the way, in terms of the particular individual, so you get a better idea of the contours here. Statistical basis of anthropometry. This is something that I would give you in a test, but you should know and you should memorize, because if you have it memorized, you'll understand how the concepts work, and it's very easy to work out the solutions. X is your sample mean, S is your sample standard deviation, X sub P is that percentile value of the variable X that we're looking at. So in this case here, we may be looking at a 90th percentile individual, a 50th percentile individual, and so on. The Z sub P, that's your standard normal value, corresponding to that percentile value of X. So these are from tables that you get in terms of where you are in that percentile of the population you're interested in. And so with all of these then set up in this following equation, you can then solve for the X sub P, or if you do some simple algebra, you can also solve for any one of these variables. So here's your Z table and your percentile that we're interested in. And as I mentioned to you, we're interested in for male and female combined, from the 5th percentile female to the 95th percentile male, and these are your Z-scores that you get. So for the 5th percentile, you have a minus 1.645. For the 95th percentile, you have a plus 1.645. So you would work that into this particular equation here for that particular value, so that you can now be able to fill in the equation to get your answer for X sub P. The ranges are from 0.5 to 99.5, so that's your full range. And notice that when you get closer to the mean, we don't have anything that says 50th, because you don't have any adjustments there, correct? You just really are looking at from the 25th percentile down and from the 75th percentile up in terms of these Z-scores. So if we were to apply this to a table, as I mentioned, you have popliteal height. If you're interested, let's say, in fitting for a chair, and buttock to popliteal length, for example. And we have our male population, our female population, our means and standard deviations. This just tells you from where they got those populations to make sure they're relevant to the population you're applying it to. We have the same information for females, but we also, it's unique to have information where we've mixed the two, and this is handy because now we're looking at male and female populations mixed here in terms of overall stature all the way down to knee-to-knee breadth. So in this case, let's say I've asked you to give me the 50-50 mixed male to female mean and standard deviation for popliteal height sitting and buttock to popliteal length sitting because I'm interested in purchasing some chairs, and I want to make sure that these chairs fit the majority of the population that I'm interested in. So we'd come down to the B7, as you can see right here, come straight across, and you can see for my mean value I'm looking at 41.9. My standard deviation is 3.4. For the buttock to popliteal length, it is now 48.7. Standard deviation is 3.2. So having this information now can help us fill in the particular equation to give us an answer about our interest in the range. So if we have a mean, as we showed here for both the sitting popliteal height, and we have the popliteal distance to buttock, for the means and standard deviation, we have our z-scores that you presented right here. Then we have all the information that we need to be able to solve for this particular population in terms of what is going to be accommodated. So if we go from one range to the other, so this would be on one end, let's say in the 5th percentile, we'd be interested, let's say, in the smaller population, and then we could also apply this in the 95th percentile, as I showed you, that 1.645 number with the standard deviation that I gave you from the table, the mean that I gave you, and gives you these values. So from this, then you can get a range of information from the small individual to the tall individual. So based on anthropometric measures taken on a randomly selected sample from a given population, the mean eye height was 160 centimeters. With a standard deviation of 12 centimeters, calculate the eye height of the 90th percentile, the 50th percentile, and the 5th percentile. So you can go ahead and do these calculations, but just to make it a little bit easier on you, as you know, we have the mean eye height's 160. So if I'm asking you for the number B, the 50th percentile, you know that because you don't have to apply that equation, because you don't have the z-scores or standard deviation in that end, you would know that would be 160 centimeters. So you can quickly do the calculations given the information that I presented to calculate A and C. So one of the problems that I asked you to work on was this the anthropometry of seat height adjustability to accommodate 90% of a 50-50 mixed male-female population. So you have all the information that I gave you a little bit earlier. And so the seat height is determined by the popliteal height plus the shoe sole thickness. So you can do all your equations independent of this, but then always remember at the end to add at least 1 inch or 2.5 centimeters in order to give you the information that you need for the minimum percentile and the maximum percentile. And so you have your range height adjustability. I'd like you to do these calculations to give me the answer from the minimum to the maximum. Don't forget to add in the shoe height. And as I mentioned a little bit earlier, the more sensitive end of the spectrum tends to deal, especially with popliteal height, tends to deal with the smaller individuals and as well as the seat pan depth. So body surface area is another one. If you're looking at a large subject, 260 pounds, 6'2", what are the steps to calculate body surface area for square meters to square feet? This information is provided here to calculate this, and the answer is that this is a constant right here. Here's your weight, so the 260 can fit in there. The height can be put in here, and so you can calculate the body surface area first from meters and then convert to square feet. Notice that this constant right here allows you to make that adjustment and use these exponents for the weight and height information that you put in, because it's obviously we're dealing with weight and we're dealing with height, and yet we come up with a dimension. And in order to get this dimension, you need this constant in order for that to play out. So anthropometry exercises, that is now recorded And you can view that. My postdoc, Dr. Sandra Cole, is a subject in this tape being measured for the anthropometry and the links used for really the hands-on aspects of understanding anthropometry and understanding that when we measure overall stature, that our links can vastly different, such as arm length, torso length, leg length, and so on. So I would have asked a class to go through. They form teams of 2 to perform the exercise, and we now have a table in which that information can be used to give us information about the variability in the population measured. One of the things that will come up in the table is the height of the seat. And as most of you know, if we're measuring that height in the seat, that one of the things that's important to know is that you're going to have some variability with that by measurement error, because all those measurements should be at 16 inches, and the reason for that is that that's the fixed height of the seat. Now, if you were to have an adjustable seat, you could move it up and down to get the proper 90-degree angle between the upper and the lower leg, and the feet are flat on the floor, including shoes. Then the seat height would be different. But in this case, it should all be the same. And so when you have a chance to look at the table, the outcomes of those measurements, one of the conclusions made is that why was there a difference between one person and the other? And the answer is measurement error, because of the fact that you have a fixed height. All those chairs are the same height at 16 inches. We go back to our equation and our z-scores. Here are the measurements here. When you're doing those measurements, remember this is your popliteal, the crease in the knee, the back of the calf to the buttock. The seat height is B7, not B6, and for seat pan depth, B9 and not B8. And recall what I mentioned about B8 and B6. This would be really clearance underneath the desk. B8 is knee clearance underneath the desk, and B6 would be clearance of the thigh with the drawer, the top of the desk, in terms of where the knee would, or the thigh would touch the drawer, and so on as it goes underneath the desk. Here are your exercises here. Remember that 2.54 centimeters equals an inch for conversions. And so if you did the equations as I've asked you to do, then you would find that your answer here for looking at 90 percentile individual, we're looking at a 175.4 centimeters for the eye height. It's 160 for the average, which means you don't apply any of these standard deviations because it's the average, the mean. And then for the 5th percentile, we're looking at 140.3. So why would you go through this exercise? It's because if you were working at a particular in a particular job, you want to make sure that the individual who is tall and those that with the lesser stature would have the same sight lines to be able to see clearly where they're standing and viewing, for example, control panels and so on and so forth. And many of you have experienced this if you're actually in a seated workstation with the monitors, placement of the monitors, where they are in terms of high or low. Answers for the other calculations that we did. Remember, we did this issue with having a standard shoe on. We do these calculations here where we have our 41.9 value minus there's our z-score value and our standard deviation right here. And we come up with the value of 36.3 on this, or 14.3 inches, plus we add the shoe. We do the same thing with the 95th percentile in terms of the mean. The z-score now is a plus, as you can see here. So it's 47.5 or 18.7 inches plus the shoe. Thus the range of seat height adjustability, if you have an adjustable height chair, would be from 38.8 to 50 centimeters. And the value of that would be, if you were ordering some chairs from a vendor, that you would find out, say, well, what's the range of height of seat adjustability that your chair has. And that helps you vet the equation a little bit in terms of what vendors you're going to work with, because if they cannot give you this kind of a range, then you may want to look for other chair manufacturers that would have this range from the small individual to the tall individual. In terms of body surface area, we came up 187.96 centimeters in height. So your body surface area right here comes out to be 2.43 square meters, or 26.15 square feet of surface area. Remember, again, this constant right here allows you to make these conversions from weight and height to surface area. And just there's just a sub-calculations right here for the exponents. If you don't have that, I do recommend that you bring a calculator to the class that does help you, give you the ability to do these exponent calculations so that you can come up with the best answer should you be given this on an exam. And that's the end of the second part of the anthropometry lecture, which also includes answers to the questions given to you in class. Thank you for your time and attention.